Hello, my name is Tor Mørne, and today I'm going to present our char 2 project, which is a carbon capture project based on capturing CO2 on the production of a carbon reduction material used in the process industry called char. In 2016, we contacted the Polish company Polchar and the Norwegian customer Elkem to talk to them about how to capture CO2 on a char and perhaps build a project together. We brought in SINTEF for research, and we brought in Air Products with their knowledge of process technology and membrane technology. And in 2017 we were funded by Gassnovas. We decided that learning from our first part of the project, that we would use the amine technology from Aker Carbon Capture, and we also decided that we would locate our production facilities in Norway, which meant moving production lines from Poland up to Kolsnes, which is the site that is right next to the Northern Lights CO2 reception facility. The reason why we chose Kolsnes was because of its proximity to the reception facility, which meant that we wouldn't have to transport our captured CO2. In addition, we were interested in the synergies with surrounding industry with regard to how we could make use of our energy that we generated from our production. In 2019, Gassnovas funded our demonstration project. We brought in addition to Polchar, SINTEF and Elkem, we brought in Aker Carbon Capture and Equinor representing Northern Lights. In this project, we are going to verify the location and the synergies, and we are going to capture CO2 this spring with Aker Carbon Capture's mobile test unit. Alex Nielsen is the president of Polchar, who is our producer of char, which is the carbon element that we will capture carbon emissions from.
We started in 1995 exporting to various European countries, specifically Norway. We are producing a product that is used in the alloy industry to produce the alloys, specifically silicon metal and ferrosilicon. We're doing it by selecting coals with specific properties so that the charring of it, which is a semi-coking of the coal, can be done within certain specifications, very strict specifications. The raw materials come from Poland, basically, that's why we're placed in Poland, and from Colombia. And those we process, and then we are measuring very strictly what the chemical and physical properties are before they're exported to the smelting industry. Our main customers are, as I mentioned, in Norway. They are very big on silicon, ferrosilicon, and it has been, and it is, various other European countries and even North Africa. We have also exported to Asia. First of all, as I said, we take coal from various sources around the world, and then we process them. And the processing is basically done by selecting the very best coals, physically and chemically, and then heating them to drive away what we call volatiles in the coal. It is basically the gases in the coal. Driving away those gases are mainly methane, and in burning them and driving them away, we will create CO2. We're not burning the coal, we're burning the gases, So there is a CO2 component in our effluents and our gases and our emissions. And we are very, very interested in reducing those CO2 gases where and whenever possible. And more to the point, get rid of them. To not just take them out, you also got to dispose them. I see it becoming profitable in that there will be CO2 taxes, there will be all these things, and if you can remove those there, you will not have to pay the CO2 taxes, and thereby you can keep the prices of your product and you can be competitive. I think that's very, very important.
Tor Mørne, he's our chairman and our concept development responsible. So tell me a little bit about yourself and your background.
Most of my life I've been busy in various applications relating to gas separation and the use of a variation of gases. So if we look at what we are doing up on Kollsnes, we are considering that we are taking in 3 different factories as turnkey elements, where the first element is delivered by Polchar with full management and training of personnel, and at the end it is the Aker carbon capture solution for CO2 capture. In the middle is where we have a lot of development work to do. The output we have from the char factory, in addition to the char itself, is also a lot of heat. We generate about 50 megawatt of power coming out in the form of a flue gas at 1100 degrees. We see also that through the developments that we now are testing out in Poland, that we will be able to even further increase the temperature during the after combustion. And we are looking for possibilities where we can utilize the power we have, not only the energy, but also the high temperatures. We see that in the combination with the ability to utilize natural gas from Equinor in a circular economy, we also see that our heat and the surroundings makes it possible for us both to produce hydrogen and ammonia. And we also do see that we can have an interesting laboratory to look at elements that can be put into a circular economy when we have that good starting point with the heat.
The timeline for the project now is that we will, provided that COVID allows it, capture CO2 with Aker's mobile test unit within the summer 2021. We are also entering into agreements with several companies that will help us with project management and legal and financial issues, so that in the autumn of 2021 we will be able to plan the establishment and in more concrete ways, and we'll also be looking for investors for the project. By 2024 we will have 2 production lines at Kollsnes producing 50,000 tons of char and 100,000 tons of CO2 that will be captured. By 2029 we will have 8 production lines generating 400,000 tons of CO2, equal the size of the Norcem capture project.